Imagine you are floating in the quiet blue of the ocean. The sun sends down long fingers of light. Below you, there is only the deep, silent water. And then, something appears. It is not a fish. It has no fins, no scales, no eyes that look back at you. It is a gentle pulse of life. A soft bell, almost clear, drifts past. Trailing behind it are long, delicate threads, like silk ribbons in the water. This is a jellyfish. It moves with a slow, rhythmic beat, a silent heart of the sea. It is a creature made almost entirely of water, a living jewel that has drifted through our world's oceans for millions of years, long before the first dinosaurs walked the land. These simple, beautiful animals are full of surprises. They seem so fragile, like a glass sculpture you could break with a single touch. Yet, they are survivors. They have lived through every great change our planet has seen. They have no brain, no blood, and no bones. If you were to hold one, it would feel like a handful of jelly. But in the ocean, it is a master of its world. It dances to a rhythm that is ancient and slow. Watching one is like watching a cloud drift across the sky. It is there, and then it is gone. A brief and beautiful moment in the vastness of the sea. Their lives are a quiet mystery. They appear in great numbers, like a sudden bloom of flowers in a desert. These gatherings, called blooms, can fill a whole bay with their soft, pulsing bodies. Sometimes there are so many that the water itself seems to be alive. They can glow in the dark, lighting up the deep ocean with their own cool, living light. This light, called bioluminescence, is a chemical magic they create themselves. It is a secret language of the dark, a silent signal in a world without sun. Their story is not one of speed or strength, but of quiet endurance and simple beauty. We often see them washed upon the shore. They look like strange, wet jewels left behind by the tide. On the sand, they lose their magic. They become still and lifeless, a small reminder of the vibrant world just beyond the waves. But in the water, they are creatures of grace. They are a fundamental part of the ocean's story, a story that is as old as the sea itself. To understand them is to understand something profound about life on our planet. It is to look into a world that is at once alien and deeply connected to our own, a world that has been pulsing with life long before we ever arrived. When we look at a jellyfish, so many questions come to mind. What are these strange and wonderful creatures really? They are not fish, as their name might suggest. They belong to a much older, simpler family of life. They are drifters, travelers on the ocean currents, moving through the water with an elegance that seems almost effortless. How can something so simple survive in a world full of fast, powerful predators? How does it find food without the ability to chase it? How does it see without eyes, or think without a brain? The jellyfish is a living puzzle, a masterpiece of simple design that has stood the test of time. Their presence raises even bigger questions about the health of our oceans. In some parts of the world, their numbers are growing. Great swarms can appear suddenly, clogging fishing nets, clogging power plant pipes. Are these blooms a sign that something is wrong? Are they a warning that the ocean's balance is changing? Scientists are working to understand what these changes mean. They study the jellyfish to learn about the ocean's past and its future. Every jellyfish is a small clue, a piece of a much larger story about the delicate web of life that connects everything in the sea. Their lives are deeply connected to ours, even if we live far from the coast. The fish we eat may depend on the same small creatures that jellyfish eat. The health of the beaches we visit can be affected by their sudden arrival. For some, they are a source of food. For others, a source of medicine. Researchers are discovering that substances from jellyfish can be used in surprising ways, from helping to heal wounds to making better solar panels. These simple animals hold secrets that we are only just beginning to unlock, secrets that could change our lives in ways we cannot yet imagine. So, let us begin a journey. Let us dive beneath the surface and enter the secret life of jellyfish. We will explore their strange and beautiful bodies, their mysterious life cycles, and their vital role in the ocean. We will meet the people whose lives are intertwined with theirs, from the fishers on the open sea to the scientists in the lab. This is not just a story about an unusual animal. It is a story about connection, resilience, and the delicate balance of our blue planet. It is a story that asks us to look closer to wonder more and to understand our place in the great, pulsing heart of the ocean. A jellyfish is a marvel of simplicity, a creature built from little more than water and a few thin layers of skin. Imagine a simple bag, soft and flexible. This is the basic shape of a jellyfish. It is called the bell, or medusa. This bell is not made of muscle and bone like our bodies are. Instead, it is about 95% water. This is why jellyfish are so transparent and seem to melt into the sea. Their watery bodies give them buoyancy, helping them float effortlessly. They are perfectly suited to a life spent drifting, carried along by the ocean's gentle hand. It is a body designed not for fighting the currents, but for joining them in their endless dance. The body of a jellyfish has two main layers of cells. There is an outer layer, like our skin, called the epidermis, and there is an inner layer, the gastrodermis, which lines its gut. Between these two layers is a thick, jelly-like substance. This substance is called mesoglea. It is what gives the jellyfish its shape and squishy texture. It acts like a simple skeleton, providing support without being heavy or rigid. This design is incredibly effective. It allows the jellyfish to be both strong enough to hold its form and light enough to stay afloat with very little effort. It is a body built for efficiency, wasting no energy on unnecessary parts. This watery construction has served them well for over 500 million years. Being mostly water means they need less food to survive than more complex animals. Their bodies are cheap to build in terms of energy. This allows them to grow and reproduce very quickly when conditions are right. It also makes them resilient. If a part of their bell is torn, some jellyfish can heal with remarkable speed. Their simple form is not a weakness. It is their greatest strength, a testament to the power of minimalist design in the grand story of evolution. They are living proof that sometimes the simplest answer is the best one. Their bodies are also a window into a different way of being. They do not have a head, a tail, a front, a back in the way we understand them. They are radially symmetrical, like a wheel, like a pie. This means their body parts are arranged around a central point. This shape is perfect for an animal that can drift in any direction. Dangers and opportunities can come from above, below, any side. A symmetrical body allows the jellyfish to respond equally well to anything it encounters, no matter where it comes from. It is a body that is open to the world in all directions at once. At the center of the jellyfish's underside, hanging down from the bell, is a single opening. This opening is its mouth. But it is much more than just a mouth. It serves many purposes. It is how the jellyfish eats its food. It is how it gets rid of waste. For many species, it is also involved in reproduction. Everything the jellyfish needs to take in, and everything it needs to release, passes through this one opening. Surrounding the mouth, many jellyfish have frilly, ribbon-like structures called oral arms. They are extensions of the mouth and crucial for feeding. When a jellyfish's long tentacles capture a small fish or a tiny floating animal, they bring the prey up towards the oral arms. The oral arms wrap around the food, covered in sticky mucus, guiding it into the mouth. In some species, the oral arms are themselves covered in stinging cells and can capture food directly. Once inside, the food enters a simple stomach, the gastrovascular cavity. It's a single hollow space in the bell where digestion and absorption happen. Canals branch out from this central space, like roads from a city center. These canals carry nutrients to the bell muscles and tentacles. After nutrients are absorbed, leftover waste is expelled the same way the food came in, through the mouth. The mouth opens and undigested material is pushed out into the water. It's a simple, efficient system, perfect for a life of drifting and waiting. Section 3. The rhythmic pulse. A jellyfish does not swim like a fish, powerfully pushing against the water. Instead, it moves with a gentle and rhythmic grace. It propels itself by pulsing its bell. Imagine opening and closing an umbrella over and over again. This is very similar to how a jellyfish moves. It squeezes the muscles around the edge of its bell, forcing water out from underneath it. This jet of water pushes the jellyfish forward or upward in a slow, silent motion. Then, the bell relaxes and opens again, ready for the next pulse. This movement is both beautiful and incredibly efficient. This pulsing action is not just for movement, it also helps the jellyfish to feed. As the bell expands and contracts, it creates gentle currents in the water around it. These currents can draw tiny, floating creatures, known as plankton, in towards the jellyfish's waiting tentacles. The pulse also helps to spread the tentacles out, creating a wider net to catch anything that drifts by. So, every beat of the jellyfish's bell is a multitasking action. It is a breath, a step, and a cast of a net all in one. It is a simple movement that serves nearly all the jellyfish's needs. The speed and rhythm of this pulse can change. If a jellyfish senses danger or needs to move more quickly, it can pulse its bell faster. If it is simply drifting and waiting for food, the pulse can be slow and almost hypnotic. Some jellyfish are stronger swimmers than others. The box jellyfish, for example, has a more complex bell shape and a more powerful pulse, allowing it to move with more purpose and speed than many of its relatives. But for most jellyfish, the goal is not speed. The goal is to stay afloat and to be in the right place at the right time, using as little energy as possible. This gentle way of moving has allowed jellyfish to colonize every ocean on Earth, from the warm surface waters of the tropics to the cold, dark depths near the poles. Their simple jet propulsion is one of the oldest forms of movement in the animal kingdom. It is a timeless solution to the challenge of living in water. Watching a jellyfish pulse through the ocean is like watching a living piece of history. It is a rhythm that has been beating in our seas for hundreds of millions of years, a slow and steady heartbeat in the great body of the ocean. Section 4. Threads of danger and delight. Trailing beneath the jellyfish's bell are its most famous and formidable features, its tentacles. These are not simply decorative ribbons. They are highly sophisticated tools for hunting and defense. They can be long and thin, like fishing lines, or short and numerous, like a thick fringe. In some species, like the lion's mane jellyfish, the tentacles can stretch for tens of meters, creating a vast and deadly web in the water. These tentacles are armed with millions of microscopic stinging cells, called nematocysts. It is these cells that make the jellyfish such an effective predator, able to capture prey much faster and stronger than itself. Each stinging cell works like a tiny coiled harpoon. It is held inside a capsule, under high pressure, with a small trigger on the outside. When something, like a small fish or a human hand, brushes against this trigger, the cell fires. It happens in an instant, faster than the blink of an eye. The harpoon shoots out, pierces the skin of the victim, and injects a dose of venom. A single touch can trigger thousands of these cells to fire at once. This is what causes the painful sting we feel if we accidentally touch a jellyfish at the beach. For a small fish, this volley of stings is instantly paralyzing. The venom of a jellyfish varies greatly from one species to another. For many, the sting is mild, causing only a slight rash or irritation. The moon jellyfish, which is very common, has a sting so gentle that most people do not feel it at all. But some jellyfish are among the most venomous animals on the planet. The box jellyfish of Australia, for example, has a venom that can be fatal to humans in just a few minutes. The venom is a complex cocktail of toxins designed to act quickly on the heart and the nervous system. It is a powerful weapon that ensures the jellyfish's fragile body is well protected. But these threads are not only for danger. They are also instruments of great delicacy. The jellyfish has fine control over its tentacles. Once prey is captured and paralyzed, the tentacles bend and shorten, lifting the meal towards the oral arms and the mouth. They do this with a slow, coordinated grace. For some tiny creatures, jellyfish tentacles can even offer a safe haven. Some small fish and crabs have evolved an immunity to the sting of certain jellyfish. They live among the tentacles, protected from larger predators by the deadly curtain that surrounds them. For them, these threads are not a trap, but a fortress. Section 5. A net of nerves. A jellyfish does not have a brain like we do. There is no central command center processing information and making complex decisions. If you look inside a jellyfish bell, you will not find a single organ that resembles a brain. This is one of the most puzzling things about them. How can an animal hunt, eat, move, and react to its environment without a brain? The answer lies in a different kind of nervous system. Instead of a centralized brain, the jellyfish has a nerve net. It is a simple web of nerve cells that is spread throughout its body, especially around the margin of the bell. This nerve net acts like a decentralized communication system. Imagine a city where information does not have to go to a central office to be processed. Instead, messages can travel directly from one point to another across a web of connections. When one part of the jellyfish is touched, the nerve cells in that area send a signal out across the net. This signal tells the nearby muscles to contract. For example, if something touches the side of the bell, the nerve net can coordinate the muscles to make the jellyfish pulse and move away from the touch. It is a simple system of stimulus and response. This simple system is enough to control all the jellyfish's essential behaviors. It coordinates the rhythmic pulsing of the bell for swimming. It controls the tentacles, telling them to fire their stinging cells and to bring food to the mouth. The nerve net allows the entire animal to act as a single, coordinated unit, even without a leader. In some more advanced jellyfish, like the box jellyfish, the nerve net is a bit more complex. They have clusters of nerve cells, called rhopalia, spaced around the edge of their bell. These clusters act like mini processing stations, giving them more refined control over their movements. The jellyfish's nerve net is a beautiful example of how life can find simple solutions to complex problems. It shows that a brain is not the only way to navigate the world. For a life of drifting and reacting, the nerve net is a perfect tool. It is fast, efficient, robust. If one part of the net is damaged, the rest can often continue to function. This decentralized system is a key to the jellyfish's survival. It allows them to be successful predators and survivors, all while being guided by a simple web of nerves instead of a complex mind. How does a jellyfish see where it is going? Most species do not have eyes in the way we think of them. They cannot see shapes or colors. They live in a world of light and shadow, not of detailed images. However, many jellyfish are sensitive to light. They have simple light-sensing spots, called ochelli. These are often located in the small sensory structures, the rhopalia, that are spaced around the edge of the bell. These ochelli cannot form a picture, but they can tell the jellyfish if it is light or dark. They can sense the difference between the bright surface and the dark depths. This simple ability is very important for a jellyfish's survival. For jellyfish that live near the surface, being able to sense light helps them stay in the right part of the water column. Many of the tiny plankton they eat are found in the sunlit upper layers of the ocean. By sensing the light, the jellyfish can move up or down to follow their food source. It also helps them with their daily migrations. Some jellyfish species move down into deeper, darker water during the day to avoid predators, and then rise to the surface at night to feed. Their simple light sensors act as a compass, guiding them on their vertical journey. Some jellyfish, however, have taken seeing to a much more advanced level. The box jellyfish are famous for having a surprisingly complex set of eyes. Each of their 4 rhopalia contains a total of 6 eyes, making 24 eyes in all. Some of these are simple pits that just detect light, like in other jellyfish. But some are true eyes, with a lens, a cornea, a retina, much like our own. Scientists have been amazed to discover these complex eyes on such a simple creature. They are still trying to understand what the box jellyfish sees with them. Even with these advanced eyes, the box jellyfish does not have a brain to process the images. So how does it use the information? Researchers believe the eyes help the jellyfish to navigate and to avoid obstacles. Box jellyfish often live in complex habitats, like mangrove forests. Their eyes may help them to steer around roots and other objects, and to stay in the calm waters where their food is plentiful. They may not see a detailed picture of the world, but their eyes give them enough information to move with purpose. It is a fascinating puzzle, a creature with camera-like eyes, but no brain to see the photograph. The word jellyfish is a simple name for a very diverse group of animals. There are more than 2,000 known species of jellyfish. Scientists are discovering new ones all the time. They are not one single family. They belong to a larger group called cnidarians. This group also includes their cousins, sea anemones, sea pens, corals. They share a simple, radially symmetrical body plan, and they all have stinging cells, nematocysts. But within this group, the variety is astonishing. Jellyfish have adapted to life in every corner of the world's oceans. Some jellyfish are huge. The lion's mane jellyfish lives in the Arctic and North Atlantic. Its bell can be over 2 meters wide. Its tentacles can be longer than a blue whale, a true giant of the sea. At the other end of the scale are tiny, almost invisible jellyfish. Some are no bigger than a pinhead, even as adults. They drift among grains of sand on the seafloor, or float unnoticed in the water column. A hidden miniature world most of us never see. Jellyfish come in a spectacular array of shapes and colors. The moon jellyfish, a translucent disc with short tentacles. The flower hat jelly, an ornate fluorescent hat found off Japan. The cannonball jellyfish, round and dense like its name. Some deep-sea jellyfish are deep red or purple to hide in the dark. Others are completely clear, almost invisible. This diversity took millions of years of evolution in different marine environments. This family of floaters isn't limited to the ocean. A few species live in fresh water. Craspedicosta sauerbai lives in lakes, reservoirs, and quarries worldwide. It's tiny, about 2 centimeters across, and its sting is harmless to humans. It spends most of its life as a polyp attached to rocks or plants. Only a few weeks each late summer does it appear as a floating medusa. Freshwater jellyfish remind us how adaptable this ancient group is. The jellyfish we see drifting in the ocean is just one half of a much longer story. This floating bell-shaped creature is called a medusa. It is the adult, reproductive stage of the jellyfish life cycle. Most jellyfish live a double life, transforming from one form to another in a process that has allowed them to thrive for millions of years. This transformation is as magical as a caterpillar turning into a butterfly, but it happens hidden from our view, deep beneath the waves. The story of a jellyfish is a story of two completely different lives. The story begins with a tiny swimming larva called a planula. After adults release eggs and sperm into the water, a fertilized egg grows into this little creature. It is oval-shaped and covered in tiny hairs that it uses to swim. It does not look anything like a jellyfish. Its only mission is to find a safe place to settle down. It swims downwards, away from the light, searching for a hard surface. A rock, a shell, a man-made structure. Once it finds a suitable spot, it attaches itself head down, and then its first life begins. It transforms into a completely different creature. This new form is called a polyp. A jellyfish polyp looks more like a tiny sea anemone or a miniature flower-like stalk. It has a small body with a mouth at the top, surrounded by a ring of small tentacles. It spends its days attached to its chosen surface, catching tiny bits of food that float past. In this polyp stage, a jellyfish can live for months or even years. It is a quiet, hidden life, a world away from the free-floating medusa. Most people will never see this stage. It is the secret childhood of these ocean drifters. This polyp is the patient, waiting stage. It endures the changing seasons, waiting for the right signal from the ocean. This signal might be a change in water temperature or the availability of food. When the time is right, the polyp will begin its final magical transformation. It will start to produce new jellyfish, releasing them into the ocean to begin the second part of their lives. This double life, stationary polyp and its floating medusa, is a brilliant strategy. It allows the jellyfish to wait out difficult times in a safe, hidden form, and then release its children when conditions are perfect for survival. The jellyfish polyp has a remarkable trick up its sleeve. It is a master of making copies of itself. Before it ever creates a medusa, a single polyp can reproduce asexually, which means without a partner. It can create a whole colony of identical polyps, all from the original one. It does this by budding. A small bump will grow on the side of the polyp's body. This bump develops its own mouth. This bump develops its own tentacles. It eventually becomes a new, complete polyp. Sometimes it separates to start a new life nearby. Other times it stays connected, forming a branching colony that looks like a tiny underwater forest. This ability to clone itself allows the jellyfish to expand its presence in an area very quickly. One single larva that successfully settles can eventually give rise to hundreds or even thousands of polyps. Each one of these polyps is a potential jellyfish factory, just waiting for the right conditions to start production. This is one of the reasons why jellyfish can suddenly appear in such massive numbers. A huge, hidden population of polyps might have been growing silently on the seabed for years, waiting for the perfect moment to release a vast army of medusae into the ocean above. It is a strategy of patience and overwhelming numbers. When the ocean gives the signal, the polyps begin the next stage of their magic. This process is called strobilation. The polyp's body begins to develop horizontal grooves, like a stack of tiny plates. Each plate develops and begins to look more and more like a miniature jellyfish. The polyp itself starts to resemble a tower of saucers. Then, one by one, from the top of the stack, downwards, the tiny juvenile jellyfish break away. These new creatures are called ephyrae. They are small, usually only a millimeter or two across, but they are free-swimming medusae at last. A single polyp can release dozens of these baby jellyfish. Each tiny ephyra pulses its way up into the water column. It is a perfect clone of all the others released from the same polyp colony. They are all genetically identical sisters. As they drift and feed on tiny plankton, they grow rapidly. Their bell fills out. Their tentacles grow longer. They begin to look like the adult jellyfish we recognize. This method of reproduction, creating vast numbers of clones, is one of the great secrets to the jellyfish's success. It allows them to take full advantage of good conditions, filling the ocean with their pulsing bodies in a sudden spectacular bloom of life. In the vast family of jellyfish, there is one species that seems to have discovered the secret to eternal life. It is a tiny animal, no bigger than your little fingernail, called Turritopsis dohrnii. It is often called the immortal jellyfish. This remarkable creature can, when faced with stress, old age, or injury, do something that seems to defy the laws of nature. Instead of dying, it can reverse its life cycle. It can travel backwards in time, returning to its earliest stage of life to begin all over again. This ability makes it, biologically speaking, immortal. It does not die of old age. Here is how it performs its trick. Show circular life cycle diagram. When an adult medusa of this species is in trouble, perhaps the water conditions are bad or it is physically damaged, it can sink to the ocean floor. Its bell and tentacles begin to shrink and are absorbed back into its body. It transforms itself into a small blob of tissue. This blob then continues to change, turning back into a polyp, the stalk-like form of its youth. It is the equivalent of a butterfly instead of dying, turning back into a caterpillar. It is a complete reset, a return to the beginning. Once it has become a polyp again, it attaches itself to a surface and starts life anew. It can then begin to bud, creating a new colony of polyps, just as it did the first time. When conditions improve, this new colony can once again release new medusae into the water, and each one of these new medusae carries the potential to repeat the cycle, to live, grow old, and then become young again. In this way, the individual does not die. It is reborn again and again. It is a continuous loop of life, a cycle of renewal that could, in theory, go on forever. Scientists are fascinated by this process. They are studying the immortal jellyfish to understand how its cells are able to reprogram themselves so completely. The secrets held within this tiny creature could have profound implications for human medicine, particularly in the study of aging and cell repair. The immortal jellyfish is a living example of nature's incredible power of regeneration. It reminds us that life can find the most astonishing solutions to the fundamental problem of survival. It is a tiny speck in the ocean that holds one of the biggest secrets in the whole of biology. In the deep, dark parts of the ocean where sunlight never reaches, many jellyfish create their own light. This phenomenon is called bioluminescence. It is not a hot light like a flame or a light bulb. It is a cold, chemical light produced by a reaction inside the jellyfish's own cells. The jellyfish can control this light, turning it on and off, sometimes in spectacular flashing displays. It is a silent, secret language spoken in the darkness of the deep sea. This living light can be used for many things: to startle predators, to attract prey, to communicate with other jellyfish. One common reason to light up is defense. Imagine a small fish trying to bite a jellyfish in the pitch black. Suddenly, the jellyfish explodes in a brilliant flash of light blue, light green light. This can startle the attacker, cause it to pause, give the jellyfish a moment to escape. The flash can also act like a burglar alarm. The bright light can attract a larger predator, which might investigate and eat the attacker. It's a clever way to call for help. Some jellyfish use light to find food. A steady, gentle glow, a pattern of slow pulses, might attract curious, smaller animals. Tiny fish crustaceans swim closer and enter the jellyfish's tentacle range. In the deep sea, where food is scarce, any lure helps. The jellyfish uses its light like a deep-sea angler dangling luminous bait in the darkness, waiting patiently for its next victim. The light has been useful to science. Osamu Shimomura isolated green fluorescent protein, GFP, from Equirria victoria. It makes the jellyfish glow green. Scientists use GFP as a marker. They attach it to proteins, they attach it to cells. Making parts of organisms glow lets researchers watch processes once invisible spread of cancer cells. Development of nerve cells. This humble jellyfish protein is now a vital tool in modern biology, all thanks to a jellyfish's silent conversation of light. The sting of a jellyfish is a marvel of biological engineering. It is delivered by millions of microscopic weapons called nematocysts. Each nematocyst is a tiny capsule containing a coiled, hollow thread like a harpoon with its rope. This capsule is under enormous pressure and has a tiny hair-like trigger on the outside. When a creature brushes that trigger, the capsule fires. The harpoon-like thread shoots out with incredible speed, one of the fastest movements in the animal kingdom. It punctures the skin and injects a dose of venom. All of this happens in less than a millionth of a second. The venom is a complex chemical cocktail, and it varies widely between species. It contains a mix of toxins, each with a different job. Some toxins cause intense pain, acting as a deterrent. Other toxins are neurotoxins, which attack the nervous system, causing paralysis. That paralysis helps capture fast-moving prey like small fish and stops them from damaging the jellyfish. Other toxins begin breaking down the prey's tissues, starting digestion before the prey reaches the stomach. Not all stings are the same. The common moon jellyfish has a very mild sting that most humans can't even feel. Its nematocysts can't penetrate our skin. It feeds on tiny plankton, so it doesn't need powerful venom. At the other extreme is the Australian box jellyfish. Its sting is among the most venomous in the world. Its venom is potent and fast-acting, designed to instantly paralyze or kill fish and shrimp. For humans, it can cause heart failure within minutes, making it extremely dangerous. The power of the sting is a secret we're only beginning to understand and use. Scientists are studying jellyfish venom for new medicines. Just as snake venom led to drugs for high blood pressure, jellyfish compounds might treat heart disease or neurological disorders. Deadly toxins in tiny controlled doses could become powerful healing tools. The jellyfish's sting, a weapon of defense and predation, may one day hold the secret to saving human lives. The pulsing bell and trailing tentacles create a unique, moving habitat in the open ocean. This world on the go attracts a surprising number of other animals. Some creatures use the jellyfish as transportation, a living bus across the vast sea. Small crabs cling to the top of a jellyfish's bell. They get a free ride. They may nibble on the jellyfish itself, or steal scraps of food the jellyfish has captured, a convenient and relatively safe way to travel. Other animals use the jellyfish for protection. The deadly curtain of tentacles becomes a safe haven for a chosen few. Some small fish have evolved immunity to certain jellyfish stings, like juvenile jack-like trevally. They swim carefully among the tentacles, protected from larger fish. The jellyfish becomes a living fortress. In return, fish may clean the jellyfish, or lure larger fish into its trap. This relationship is a delicate dance. The young fish must be careful. Resistance isn't perfect. A clumsy move can be dangerous. As they grow, they must leave and venture into the open ocean. For a crucial part of their youth, the jellyfish provides an essential service. This partnership shows how interconnected ocean life is. One animal's weapon is another's shield and nursery. A beautiful example of cooperation in a seemingly competitive world. Even in death, a jellyfish provides a service. When it dies, its body sinks toward the deep ocean floor. This event is called a jellyfall. In the deep sea, where food is scarce, a dead jellyfish is a huge gift. Crab shrimp, hagfish. Other deep-sea scavengers gather to feast. A single large jellyfish can feed many inhabitants of the dark depths. From moving home to death as a banquet, the jellyfish supports a whole community of other creatures. Sometimes conditions in the ocean become just right for jellyfish. The water temperature is perfect. There is plenty of food. There are few predators. Hidden colonies of polyps on the seabed respond. They release vast numbers of tiny medusae. All at once. The medusae grow quickly, and soon the ocean is filled with them. A massive gathering like this is called a bloom. It can be breathtaking. The water can become so thick with pulsing bodies it looks like a living soup. A bloom can cover many square kilometers of surface. Blooms are a natural part of the jellyfish life cycle. They show a strategy of patience and explosive growth. For millions of years, jellyfish have bloomed when the time was right, playing their role in the ocean's ecosystem. During a bloom, they consume huge amounts of plankton, transferring energy up the food chain. They become food for animals like sea turtles, sunfish, seabirds, Blooms are temporary but powerful. Recently, scientists have noticed blooms are more frequent, widespread, and longer lasting. There are several possible reasons. Human activities are changing the oceans in ways that favor jellyfish. Overfishing removes competitors and predators. Warmer ocean temperatures let some species grow faster and expand. These blooms can cause real problems for people. They can clog power plant and desalination intakes. They can fill and break fishing nets. They can close beaches and hurt tourism. While natural, increasing blooms may be a warning. The beautiful, silent sea of jelly could be the ocean's message that it's under stress, you know? For centuries, people have sailed the oceans in search of fish. But, in some parts of the world, a new kind of harvest is becoming more common. Fishers are now casting their nets not for cod tuna, but for jellyfish. This may seem strange, but jellyfish have been a part of human diets for a very long time, especially in Asia. China, Japan. Korea, certain types of jellyfish are considered a delicacy. They are valued not for their taste, which is very subtle, but for their unique, crunchy texture. This growing demand has turned jellyfish from a nuisance into a valuable catch. The jellyfish harvested for food are typically larger, more rigid species, like the cannonball jellyfish. These jellies have a firm bell that holds up well during processing. After they are caught, the jellyfish go through a long, careful preparation. Tentacles are removed, oral arms are removed. The bell is treated with a mixture of salt and alum. This process takes several weeks. It removes most of the water from the jellyfish's body and firms up its texture, turning the soft, wobbly bell into something that resembles a crisp slice of cucumber. The final product is a preserved, ready-to-eat food that can be shipped around the world. This rise in jellyfish fishing is connected to another human impact on the oceans: overfishing. As traditional fish stocks decline, fishers have to find new ways to make a living. Jellyfish offer an alternative. In some areas where fish populations have collapsed, jellyfish numbers have boomed. They have fewer competitors and fewer predators. For some fishing communities, this has been an unexpected opportunity. The same nets that once brought in schools of fish can now be used to haul in swarms of jellyfish. It is a sign of how our relationship with the sea is changing. However, this new fishery is not without its questions. Scientists are still learning about the role that large jellyfish populations play in the ocean. Removing millions of them could have unforeseen consequences for the marine food web. We do not yet fully understand how these large-scale harvests will affect other species, from the tiny plankton they eat to the sea turtles that prey on them. The jellyfish fishery is a perfect example of our complex relationship with the ocean. It is a story of adaptation and opportunity, but also a reminder that we must be careful and thoughtful about how we use the sea's resources. Let us meet a man named Ken. Let us meet a man named Ken. Let us meet a man named Ken. For 30 years, Ken has been a fisher in a small coastal town. He grew up on his father's boat, learning the rhythms of the tides, the secret places where the best fish could be found. For most of his life, jellyfish were just a problem. They would clog his nets, making it hard to pull them in. They would sting his hands as he sorted his catch. He and the other fishers saw them as a sign of a bad day, a worthless and annoying part of the job. They were something to be thrown back into the sea with a curse. He never imagined that one day they would become his most important catch. About 10 years ago, Ken noticed a change. The fish he had always relied on were becoming harder to find. His catches were smaller, he had to travel farther out to sea. At the same time, the jellyfish seemed to be everywhere. The blooms were bigger and lasted longer than he had ever seen before. For a few years, things were very difficult. His income dropped. Many of his friends left the fishing business altogether. Ken felt like the ocean he knew was disappearing. He felt a deep sense of loss for a way of life that seemed to be ending, a tradition passed down through his family. Then, a buyer came to his town. He was looking for jellyfish. He offered a good price for them, explaining they were in high demand as food in other parts of the world. At first, Ken was skeptical. It seemed absurd to fish for the very things that had caused him so much trouble. But with few other options, he decided to give it a try. He learned how to spot the best species, the cannonball jellies, and how to handle them. To his surprise, the business was good. On some days, a net full of jellyfish was worth more than a net full of the fish he used to catch. Today, Ken is a jellyfish fisher. His work has changed, but he is still on the water, still reading the ocean's moods. His story is a human story of adaptation. He did not give up when his world changed. He changed with it. He still worries about the health of the ocean. He sees the explosion in jellyfish numbers as a sign that things are out of balance. But he also feels a strange new respect for these creatures. They are no longer just a nuisance. They are survivors, just like him. They are a source of income for his family and his community, a surprising gift from a changing sea. Imagine a perfect summer day. The sun is shining, sky clear blue, a gentle breeze blows. Families pack their cars, towels, umbrellas, buckets, spades. Cars head to the beach, excited faces swimming and playing in cool water. They arrive and see a sign, purple flag, flapping jellyfish symbol sign, close up, beach closed, dangerous jellyfish. Water now off limits, empty shoreline. Happy splashing turns to quiet disappointment. Children upset. This scene grows more common worldwide. Jellyfish blooms drift into popular bays. Portuguese man-o-war, close-up dense swarm of small jellyfish close-up. Beachgoers, frustrated lifeguards warning people, lifeguard treating a sting. Unpleasant encounter between people and the changing ocean. These closures have real economic impact. Coastal towns depend on tourism. Hotels, restaurants, shops. When beaches close for days or weeks, income disappears. A large bloom can ruin a town's summer. Local authorities face a hard choice. They must keep people safe, but closing hurts the economy. No easy solution. Public safety versus economic survival. Closed beaches change our relationship with the ocean. The sea as joy and recreation now feels hostile when full of stingers. Fear and anxiety about what's beneath the surface. A small but important way ocean imbalance touches our lives. The closed beach is more than inconvenience. It is a clear message. Marine health tied to our happiness and well-being. Section 4. A scientist's quest. In a laboratory filled with bubbling tanks and glowing screens, a scientist named Dr. Ana Garcia spends her days trying to understand the secrets of jellyfish. Ana is a marine biologist, and she has dedicated her life to studying these fascinating creatures. Her work is not just about understanding their biology. It is about figuring out their role in the wider ocean and what their growing numbers mean for the future of our planet. She looks at them not as simple, brainless animals, but as important messengers from the sea. Her quest is to learn how to read the message they are sending us. Ana's research takes her from the lab to the open ocean. Some days she is on a boat, carefully collecting samples from a massive jellyfish bloom. She measures their size, checks their health, and analyzes the water they are living in. She wants to know what conditions lead to these huge gatherings. Is it the water temperature? The amount of food available? The absence of predators? Back in the lab, she studies their DNA to understand how different populations are connected. She uses complex computer models to try and predict where and when the next big bloom might occur. It is like being a detective, piecing together clues to solve an ocean-sized mystery. One of Anna's biggest questions is about the long-term impact of jellyfish on the food web. When jellyfish bloom, they eat enormous quantities of plankton, the tiny organisms that form the base of the entire marine food chain. Anna is studying how this affects other animals, like small fish, that also depend on plankton for food. She is concerned that if jellyfish continue to increase, they could fundamentally change the structure of ocean ecosystems. They could create a world with fewer fish and more jellyfish, a less diverse and less resilient marine environment. Her work is a race against time to understand these changes before they become irreversible. Anna's quest is driven by a deep sense of curiosity and a passion for the ocean. She sees the beauty and complexity in jellyfish, even as she studies the problems they can cause. She believes that by understanding them, we can learn important lessons about how to better care for our oceans. Her work is not just for other scientists. She spends time talking to fishers, to local communities, and to policymakers, sharing what she has learned. She knows that science alone cannot solve the problem. The message from the jellyfish is for everyone, and her mission is to help us all understand it, Section 5. Invaders on the current. The world's oceans are connected by massive currents, forming a global superhighway for marine life. For millions of years, currents distributed species around the planet, but now humans added a faster transport system. Ships. Huge cargo ships cross our oceans every day. They carry more than just containers. They also carry water in their ballast tanks. Water is taken on in one port to keep the ship stable and released in another port, thousands of miles away. That water carries a hidden cargo of tiny marine organisms, including jellyfish polyps and larvae. Released in a new place, these tiny jellyfish can become invasive. Not native, they can cause serious problems. A new harbor might have no natural predators to control them. The water conditions might be perfect for them to thrive. One clear example, the comb jelly, Nemiopsis lidii, native to the Atlantic coast of the Americas. In the 1980s, it was accidentally introduced into the Black Sea via ballast water. With no predators and plenty of food, its population exploded. The impact on the Black Sea was catastrophic. The comb jellies consumed massive amounts of zooplankton, the same food local fish relied on. They also ate fish eggs and larvae directly. Within a decade, the anchovy fishery had completely collapsed. The ecosystem was thrown into chaos, all from a small jellyfish that hitched a ride. It's a powerful warning about unintended consequences. It shows how easily we can disrupt delicate ecological balances. Today, there are rules to prevent this. Ships must treat ballast water or exchange it in the open ocean, far from coasts. But the problem hasn't gone away. New invasions keep being discovered. The comb jelly story is a stark reminder. The world's oceans are not isolated. They are a single, connected system. What we do in one part can have devastating effects thousands of miles away. Section 6. A city's thirst. Many of us take it for granted that when we turn on a tap, clean water will come out. But for millions of people living in coastal cities, especially in dry regions, that water comes from the ocean. It is produced by desalination plants, large industrial facilities that remove salt from seawater to make it drinkable. These plants are a marvel of modern engineering, providing a vital lifeline for growing populations. They work by drawing in huge volumes of seawater through massive intake pipes, and this is where they can run into a problem with our gelatinous friends, jellyfish. When a large jellyfish bloom moves into the coastal area, it can cause a complete shutdown. The plant's intake pipes act like giant vacuum cleaners, sucking in everything in their path. If the water is thick with jellyfish, the pipes can become completely clogged. The filters designed to protect them can also become clogged. The jellyfish bodies create a thick, slimy barrier that blocks the flow of water. To prevent serious damage to the expensive equipment, the entire plant must be shut down. Workers then have the difficult and unpleasant job of clearing away tons of dead and dying jellyfish. A shutdown like this is more than just an inconvenience. For a city that relies on desalinated water, it can be a serious crisis. Water supplies can run low, and authorities may have to implement emergency water restrictions. The same problem affects coastal power plants, which draw in huge amounts of seawater for cooling. A jellyfish blockage can force a power plant to shut down, leading to blackouts. In 2013, a nuclear power plant in Sweden had to be shut down because of a massive bloom of moon jellyfish. These events are becoming more frequent as jellyfish populations increase in many parts of the world. This conflict between our industrial needs and the natural world highlights our vulnerability. It shows how our complex technological systems can be disrupted by one of the simplest life forms in the ocean. Engineers are now working on new ways to protect these vital facilities from jellyfish. Better screening systems, bubble curtains diverting jellyfish away from the pipes, robotic systems to clear blockages. The problem of jellyfish clogging our pipes is a direct and costly consequence of changes in our oceans, forcing us to adapt and innovate in response. Just as we check the weather forecast to decide if we should carry an umbrella, people in the future might check the jellyfish forecast before heading to the beach or going out on their fishing boats. Scientists around the world are working to create systems that can predict the movement of jellyfish blooms. This is a very complex task. It involves combining many different types of information. Satellites measure sea surface temperature. Satellites measure ocean color. Ocean current data predicts where a bloom might drift. People on the water are another crucial part of the forecast. Citizen science plays an important role. Smartphone apps let fishers, sailors, swimmers, beachgoers report sightings. A person takes a photo of a jellyfish. The phone's GPS records location and time. Reports are uploaded to a central database, forming a real-time map of sightings. Thousands of ordinary reports are incredibly valuable. They help scientists track blooms as they move and verify computer models. The jellyfish forecast helps us live alongside these creatures more safely and efficiently. It gives beach managers days' warning that a bloom is approaching. This lets them prepare, put up signs, inform the public, reducing stings and avoiding closures. Fishers can avoid areas where nets would clog. Power and desalination plants get early warnings to activate defenses or plan shutdowns. The forecast marks a shift. See jellyfish as a natural phenomenon to understand and adapt to. Knowledge and preparation, not conflict. High-tech science plus community observation helps us navigate our relationship with ancient ocean drifters, a hopeful sign we can coexist smarter with the changing sea. Our journey into the secret life of jellyfish, from the sunlit surface to the dark abyss, from the microscopic world of a single stinging cell to the vast expanse of a bloom that fills the sea. We began with a moment of wonder, watching a silent pulsing bell drift through the blue. We have learned that this simple creature made of little more than water is a masterpiece of survival. It is an animal with no brain, no bones, and no blood yet. It has outlasted the dinosaurs and thrived through every major change our planet has seen. Its story is a powerful lesson in the quiet strength of simplicity and resilience. The jellyfish teaches us that there are many ways to be successful in the world. It does not possess the speed of a tuna or the power of a shark. Instead, it relies on patience, efficiency, and an almost magical ability to adapt its life cycle, with its two distinct forms. The hidden polyp and the floating medusa is a brilliant strategy for navigating the uncertainties of ocean life. It can wait for years in a safe, quiet form and then burst forth in incredible numbers when the time is right. The jellyfish reminds us that strength does not always come from force, but from flexibility and the wisdom to yield and wait. We have seen how these creatures have mastered their world through strange and wonderful tricks. They create their own light in the eternal darkness of the deep. Some, like the immortal jellyfish, have even conquered death itself, holding the secret to reversing the aging process and beginning life anew. They are hunters, armed with microscopic harpoons of incredible speed and precision. Yet, their deadly tentacles can also provide a safe haven for small fish, creating a moving fortress in the open ocean. The jellyfish is a living paradox, a creature of danger and delight, a simple being full of complex secrets. From this watery world, we can draw a profound wisdom. The jellyfish embodies a life lived in harmony with the currents, not in a struggle against them. It is a creature that is almost one with its environment, a living part of the ocean itself. Its existence challenges our own ideas about what it means to be alive, to think, and to perceive. By looking closely at this ancient drifter, we learn to appreciate the incredible diversity of life on our planet and the countless ingenious solutions that evolution has found for the challenges of existence. The jellyfish is not just an animal. It is a philosophy, a lesson in letting go, and a testament to the enduring power of life itself. Our exploration has also shown us the story of the jellyfish is deeply connected to our own. The increasing frequency and size of their blooms are not just a strange natural event. They are a message. They are a sign that the delicate balance of our oceans is changing and that our actions are the primary cause of this shift. For millions of years, the ocean has existed in a state of complex equilibrium, competing, cooperating, and keeping each other in check. The rise of the jellyfish suggests that this ancient balance is being tilted. We have seen how our activities can create a world that is more favorable for jellyfish. Causes of jellyfish blooms. Overfishing. When we overfish the seas, we remove the very animals that compete with jellyfish for food. We also remove the predators that would normally eat them. Lions, zebras, and being surprised when the grass grows out of control. We are simplifying the complex web of ocean life, and jellyfish are perfectly suited to thrive in this new, simpler world. Their ability to reproduce quickly and consume vast amounts of plankton allows them to dominate ecosystems where their competitors have vanished. Climate change is also playing a major role. As we warm the planet, we warm the oceans. For many species of jellyfish, warmer water means they can reproduce faster and for longer periods of the year. It also allows them to expand their territories, moving into areas that were once too cold for them. Pollution from our farms and pollution from our cities runs into the sea, creating low-oxygen dead zones where few animals can survive. But jellyfish, with their low metabolism, can tolerate these conditions much better than fish can. We are, in many ways, accidentally creating the perfect habitat for a jellyfish takeover. The story of the jellyfish is therefore a cautionary tale. It holds up a mirror to our own impact on the planet. The beautiful pulsing blooms that can close our beaches and clog our power plants are a symptom of a much larger problem. They are a visible sign of the invisible changes we are making to the ocean's chemistry and biology. The jellyfish are not the problem itself. They are the messengers, delivering a clear warning. They are telling us that the ocean is under stress, and that its intricate, life-sustaining balance is in jeopardy. It is a message we must listen to with urgency and humility. Faced with such a large and complex issue, it is easy to feel overwhelmed. It is easy to think that the problem is too big and that the actions of one person cannot possibly make a difference. But this is not true. The ocean is a vast, interconnected system. Small negative actions can add up to create a large problem. Small positive actions can combine to create a powerful solution. The journey from wonder to wisdom is not complete until it leads to action. There are simple, practical steps that each of us can take in our daily lives to help restore the ocean's balance and protect its future. One of the most important things we can do is to be more thoughtful about the seafood we eat. By choosing seafood that is sourced sustainably, we can help to reduce overfishing. Look for labels and guides that tell you which fish are caught or farmed in ways that do not harm the ocean's health. When we support responsible fisheries, we help to ensure that populations of fish can recover. This, in turn, helps to restore the natural competition that keeps jellyfish numbers in check. Every meal is a choice, and by making informed choices, we can vote with our forks for a healthier ocean. We can also work to reduce our carbon footprint. The warming of our planet is the warming of our oceans, and this is a major factor driving the increase in jellyfish populations. Simple changes, like using less energy at home, walking or cycling instead of driving, and reducing our overall consumption, can make a real difference when multiplied by millions of people. Supporting policies and technologies that promote clean, renewable energy is another crucial step. Protecting the climate is protecting the ocean. The two are inextricably linked, and the fate of the jellyfish and the fish hangs in the balance. Finally, we can help to reduce the flow of pollution into the sea. This means being careful about what we pour down the drain and reducing our use of single-use plastics that so often end up in the ocean, harming all marine life, including jellyfish predators like sea turtles. We can participate in local beach cleanups or support organizations that work to protect our coastlines. By becoming a voice for the ocean in our own communities, we can help to raise awareness and inspire change. Every piece of plastic removed, every sustainable choice made, is a small ripple of hope that can spread across the great blue heart of our planet. Our journey is coming to an end. But the story of the jellyfish is far from over. These creatures have been pulsing through the oceans for more than 500 million years, and they will likely be here for millions more. They are a symbol of endurance, a living link to the planet's deep past, a messenger for its future. They have shown us that even the simplest forms of life hold astonishing secrets and profound lessons. They have taught us about resilience, adaptation, the delicate interconnected dance of life in the sea. They have shown us that our world is far more strange and wonderful than we can ever fully imagine. The next time you stand on a shore and look out at the vast expanse of the sea, or perhaps see a single gelatinous jewel washed up on the sand, perhaps you will see it differently. You might see not just a strange blob, but a survivor, a time traveler, a master of minimalism. You might see a hunter, a home, a source of medicine, and a messenger. The jellyfish invites us to look closer, to ask questions, and to never lose our sense of curiosity about the natural world. It reminds us that there are entire universes of life all around us, full of stories waiting to be understood. The future of the oceans and of the jellyfish within them is now intertwined with our own. The increasing blooms are a challenge, but they are also an opportunity. They are an opportunity to learn, to adapt, and to change our ways. They call on us to become better stewards of our blue planet, to manage our resources more wisely, and to restore the balance we have disturbed. The jellyfish forecast, the new fisheries, the scientific discoveries, all of these are signs that we are beginning to respond to the message, to move from being the problem to becoming the solution. Let us carry this sense of wonder with us. Let us remain curious about the silent, pulsing heart of the sea and all its inhabitants. The jellyfish is a humble creature, but it has a great story to tell. It is a story of survival, of change, and ultimately of hope. It is a hope that we can learn to live in better harmony with the natural world a hope that we can protect the intricate beauty of our oceans for all the generations to come. The endless dance of the jellyfish continues, a silent, rhythmic beat in the deep. And it is up to us to ensure that the ocean it dances in remains healthy, vibrant, and full of life.